Bismillahirrahmanirrahim. In the last section, we discussed the limit at a finite number, that when x goes to some real number a, and we gave different type of examples. In this section, we are going to speak about the limit at infinity, how to find the limits at infinity. Before giving an example, let's start with some theorems and some rules for how to find the limits at infinity. In the last example, we spoke about the function 1 over x. One over x. And we said that the function 1 over x take this shape. For the positive and negative, it is undefined when x equal to 0. So we have something called the vertical asymptote at x equal to 0. Now this function 1 over x, we found the limit of this function when x goes to 0, from left or from right. In this section, we are going to speak about how to find the limit when x goes to either plus infinity or x will go to minus infinity. X goes to plus infinity or x goes to minus infinity. For this function, the limit when x goes to plus infinity, you can see as we move to the minus infinity in this direction, the function will go to 0. Because we know that the limit of the function means the value of y. It is the output of the function. If we divide by a very big number, the overall value will be very small or approaching the 0. So the limit of 1 over x as x equal to or goes to plus infinity is equal to 0. And also the limit of 1 over x, where x goes to plus or minus infinity, also is equal to 0. So dividing by 1 or over a big number, that will be approaching the 0, either from left or from right. Second one that will be used in this topic or in this part, limit of a function f of x to power n as x goes to either plus or minus infinity. We can take the limit inside. The limit of the function. To power n. Third one, limit of x goes to either plus or minus infinity of a function multiplied by constant. The constant can be taken out and multiplied by the limit of the function. Plus or minus infinity. With one more rule, that if I have limit of f of x plus or minus g of x this is equal to the limit f of x plus or minus g of x. Limit. This will be the basic idea for this function, plus one more, that if I have polynomial limit of f of x, or that if polynomial as x goes to plus or minus infinity of some polynomial, let's say c n x to power n plus c n minus 1 x to power n minus 1, keep going like this, c1 x to power 1 plus c0, this will be equal to the limit of the highest power. Taking the limit of the highest power. This will be very useful. Now let's apply this for some examples. Compute the limit. Number one, limit 3 divided by x, where x goes to plus infinity. This is a finite divided by a very large number, which is 3 divided by x, where x goes to plus infinity, is equal to 0. This is the first part of the theorem. Limit of 3 divided by x, where x goes to plus infinity or minus infinity, I will have 0. Number two, limit of 2x squared minus 4x plus 3, where x goes to minus infinity. Now this is limit of a polynomial. If we have polynomial, we are taking the limit of the highest power in the polynomial. Take the highest power in the polynomial. So this will be equal to limit of 2x squared as x goes to minus infinity. Now 2x squared, now x goes to minus infinity is negative, but with the square it will be positive. So this will be 2 multiplied by plus infinity. That will be plus infinity. So I will have plus infinity. So for this example, I will write a remark. Now the limit of the x to power n, limit x to power n. If x goes to plus infinity, so the answer will be plus infinity. Number one. Number two, limit of x to power n, where x goes to minus infinity. In this case, I will have two cases. Either it will be plus infinity if n is even number. If the power is even, 2, 4, 6, or 8, then the limit will be plus infinity. And it's equal to minus infinity if n is odd. So even means 2, 4, 6, 8, and odd means 1, 3, 5, 7. These are odd numbers. So the limit of x power n if x goes to minus infinity will be plus infinity if the power is even, and it is equal to minus infinity if the power is odd. Applying this to more examples. Example number 3 is find the limit of the function 5x to power 3 minus 4x plus 10, where x goes to minus infinity. So as we said, for the polynomial, we are taking the limit of the highest power. This is equal to the limit of the highest power, which is 5x to power 3. Don't forget that we are using also taking the coefficient of the highest power, because sometimes the sign of the coefficient will change the limit. So we have to keep this with the highest power. We have to take the whole term, the coefficient plus the variable with the highest power, as x goes to minus infinity. Now, the power in this case is odd. So x to power minus goes to minus infinity will be negative. So this will be 5 multiplied by minus infinity. X to the power 3, where x goes to minus infinity, is minus infinity. So it is 5 multiplied by minus infinity, which is equal to minus infinity. So the limit for this function is equal to minus infinity. One more example. Number 3. Limit of minus 2 x to power 4 plus 3x square minus 5x plus 7, where x goes to plus infinity. X goes to plus infinity. Same thing. Take the limit of the highest power. So this is the limit of minus 2 x to power 4, where x goes to plus infinity, which is equal to minus 2 multiplied by limit of the power. I have x to power 4. Just keep the coefficient upside down. It is constant, take it out, minus 2. Now, the limit of x to power 4, where x goes to plus infinity, is plus infinity. So it is minus 2 multiplied by plus infinity, but be careful. The coefficient is negative, or the coefficient is negative in this case. It is minus 2. Minus multiplied by plus, I will have minus infinity. And that's why I said that you have to be careful about the coefficient. Sometimes this will change the sign of the limit at the end. So don't forget, when you take the limit of the highest power, you have to keep the coefficient with the highest power. So it is minus 2 multiplied by plus infinity equal to minus infinity. Now let's speak about the rational functions. Number 4. As we did in the last section, we spoke about the rational functions. We'll do the same thing here. Limit of 3x to the power 3 minus 4x plus 5 divided by, let's say, 2x to the power 3 minus or plus 7x plus 10 divided by, or x goes to plus infinity. You can see that I have polynomial divided by another polynomial. This polynomial divided by another polynomial. So we can apply the limit of the highest power for the numerator and the denominator. So just to make it easy for this one, I'm going to take the highest power from the numerator and the highest power from the denominator. So this is equal to 3 x to the power 3 divided by 2x to power 3, where x goes to plus infinity. Now, before taking the limit, we can simplify. I can cancel x to power 3 and x to power 3. So the remaining will be 3 over 2. So the limit in this case is 3 over 2. So we can say in general, if the power of the numerator and the denominator are equal, then we take the coefficients up divided by the coefficient down. We add this if, okay, in this case, limit a x to power m divided by b x to power n, where x goes to either plus or minus infinity. If the power equal, now if m is equal to n, the limit will be a over b. Take only the coefficients. If the powers are equal in the numerator and the denominator, just take the coefficient, that will be a over b. Number 5, example number 5. Let's find the limit of 4x to the power 5 minus 10x squared plus 3x minus 7 divided by x to the power 6 plus 2x minus 15, where x goes to minus infinity this time. Again, since I have polynomial divided by a polynomial, be careful about this one. Speaking about polynomial, if I have polynomial divided by another polynomial, take the highest power up and down. So this is equal to the limit of the highest power up is 4 x to the power 5. Highest power down, x to the power 6, as x goes to minus infinity. Now, simplify. I have x to the power 5 will be cancelled with x to the power 6 down. So all what I have will be 4 over x to the power 1. This is 4 over x, where x goes to minus infinity. And this will give me 0, as was stated in the, so this will be 0 as stated in the theorem. So the limit of this function is equal to 0. And you can see that in this case, the highest power up is less than the highest power down. M less than n. And this is the second case. That's what number 1. This is number 2. If m is less than n, the limit will give me be 0. So the limit is equal to 0. If the highest power up is less than the highest power down, the limit will be 0. Third one, or next example, let's just reverse. If I have for x to the power 6 minus 10x squared plus 3x plus 7 divided by x to the power 5 plus 2x minus 15, as x goes to minus infinity or plus infinity. It is the same concept. So taking the highest power for the numerator and the denominator, I will have 4x to the power 6 divided by x to the power 5. So I take the highest power. As x goes to minus infinity. If we simplify, 6 with 5, I will have 4, or the limit for x to power 1 as x goes to minus infinity. And this is equal to 4 multiplied by minus infinity. Because the limit of x to power 1, the power is odd, x goes to minus infinity, I will have minus infinity. So 4 multiplied by minus infinity will be minus infinity. So these are three cases for the rational function where the numerator and denominators are polynomial. Take the highest power. If the power up equals the power down, we'll take the coefficients a over b. If the power down is bigger than the power in the numerator, it is equal to 0. If it is the reverse, it will be either plus or minus infinity, depending on the power and the coefficient of the highest power. Number 7. Find the limit of this function, which is that is 3 x squared plus 4 to power 3 multiplied by 1 minus x to power 3 all to power 4 divided by x to power 3 plus 5 multiplied by x to power 15 minus 9, where x goes to plus infinity. Now for this example, I have a polynomial divided by another polynomial, but it's written as a factor, product of two factors. So we have two ways to write this rational function. Either I will open the brackets up and down, multiplied, just expand the brackets, then multiplied, and see whether the powers are equal for the numerator and the denominator or not. Or just take the highest power from each bracket. Take the highest power for each bracket. To make it easier, we are going to take the highest power for each bracket. We will not open the bracket, we will not product anything or multiply anything. So this will be equal to limit. The highest power for the first bracket is 3 x squared. But I have power outside, external power. We have to keep that one also. 3x squared all to power 3. Now the second bracket, I have minus x to power 3 and all to power 4. In this way, we will guarantee that we will get the highest power for the numerator. We are taking the highest power with the coefficients with the negative sign for the second bracket. So the first bracket will give me 3x squared all to power 3 multiplied by minus x to power 3 all to power 4 divided by the highest power down is x to power 3 for the first bracket multiplied by x to power 15 for the second bracket as x goes to plus infinity. Now this will give me limit of 3 to power 3 will be 27. X to power 6 multiplied the powers. 3 to power 3 will be 27 and the powers will be multiplied. 3 multiplied by 2 is equal to x to power 6 multiplied by minus 1 to power 4 will be plus 1 and x to power 3 all to power 4 will be x to power 12. So this will be x to power 12 divided by x to the power 3 multiplied by x to the power 15 is equal to x to the power 18. For the multiplication, we add the powers. X to the power 15 plus 3 will give me 18. Add the powers. So this is equal to limit of 27 up will be x to the power 18 divided by x to the power 18, where x goes to plus infinity. Now simplify. I have x to the power 18, will cancel x to the power 18, so the final answer is equal to 27. So the limit for this function is equal to 27. So no need to open the bracket, especially if I have a very big power. So we will take the highest power inside and raise it to the power outside. Take the highest power, keeping the power outside the bracket also. That will make it easier to find the highest power for the numerator and the highest power for the denominator. Then simplify it by cancelling these powers if they are equal, or if they are not equal, we can simplify, taking the common factor. And then we can find the limit of the rational function.